So today we're going to talk about sine, cosine, and tangent when it's not just acute angles. So when we can't necessarily just draw a regular 30, 60, 90 or 45, 45, 90 triangle and use SOHCAHTOA to figure out what the trig values are. We are talking about exact values today, so no calculators. And first, I want to point out when we're talking about these trig values, we're going to generally say related angle, which means exactly the same thing as reference angle when we were doing vectors and polar coordinates. And I will tell you right now, I'm going to use them interchangeably. So related and reference angles really are exactly the same thing. We saw that when we were doing polar coordinates and vectors, we drew our reference triangles in the appropriate quadrant, and then we figured out the ratios that we needed for R and for our angle rho. We're going to still be doing the same thing. The only thing that's going to change is depending on which quadrant we're in. Sometimes we're going to have positive answers and sometimes we're going to have negative answers for sine, cosine, and tangent. But when we're doing our 30, 60, 90, and 45, 45, 90 triangles, we're still going to be talking about numbers like 1 over 2, or 1 over the square root of 3, or the square root of 3 over 1, or the square root of 3 over 2, just sometimes positives and sometimes negatives. That's going to be the only difference when we do negative angles and we do angles bigger than 90 degrees. So first thing that I want us to talk about is what's positive and what's negative in which quadrant. Before we start putting all of our numbers in, let's make a little bit of sense out of that. Now, we already know that if we had everything positive, if we just had some sort of a regular angle here and we were in the first quadrant, we know everything's positive. All of the ones that we've done so far, sine, cosine, and tangent, have ended up being positive. So I'm not going to take a lot of time going through that quadrant. Let's look, though, if we had an angle that brought us around somewhere so that we landed in the second quadrant. So we'd be talking about this. We are going to always, always, always draw our triangles using the horizontal axis. At least we're consistent in math. Whether we're doing polar coordinates or we're doing vectors or we're doing angles of depression, angles of elevation, we like the horizontal lines and we do not use the vertical ones. So we're consistent. So that should make it easy to remember. So this right here is going to be our related angle, just like we did the reference angles before. So if this were my theta, in this particular case, I'd take 180 minus that so that I'd know what my related angle is. Now, if I'm in the second quadrant, if I think about coordinates, this would be going in the negative direction for the first quadrant, positive for the second coordinate, and I'm always going to consider the hypotenuse to be positive. So now for this reference angle, the one with the x-axis, if I wanted to do cosine, adjacent over hypotenuse would be negative over positive, so that would be negative. Sine would be opposite over hypotenuse, so positive over positive. And tangent would be opposite over adjacent, positive over negative, would be negative. So in this quadrant, out of these three, sine, cosine, and tangent, only sine is positive. When I was in the first quadrant, all of them were positive. So now let's see what happens in quadrant 3. If I had an actual angle that brought me around somewhere into the third quadrant, I'd be looking at this. I'm going to make my triangle with the x-axis. So here is my reference angle. For this one, I'd be going negative for the first coordinate, negative for the second coordinate. I like that triangle very well. That looks better. And hypotenuse always positive. So now for this reference angle right here, if I wanted to take cosine, adjacent over hypotenuse would be negative. Sine, opposite over hypotenuse would be negative. Tangent, though, would be opposite over adjacent, negative over negative, would be positive. So in this quadrant of those three, only tangent is positive. And finally, fourth quadrant, if I landed over here, I would have positive for my first quadrant, for my first coordinate, negative for my second coordinate, and positive for the hypotenuse. So for this reference angle with the x-axis, my cosine would be adjacent over hypotenuse, positive over positive would be positive. Sine would be opposite over hypotenuse, negative over positive would be negative. Tangent would be opposite over adjacent, negative over positive would be negative. And only cosine would be positive. So as I start to memorize my trig values, or if I'm just wanting to double check as I draw these triangles, which is what we're going to do for a while, it might be nice if I could at least know, oh, in this quadrant, here's what was positive, here's what was negative. So it might be nice if I could come up with a way to remember in the first quadrant all, in the second quadrant sine, in the third quadrant tangent, and in the fourth quadrant cosine. So it might be nice if I could memorize that, but I'm not very good at memorizing all sine, tangent, cotangent, or cosine, so I'm going to try to think up a sentence. All students take calculus would help me remember. All, if I'm in the first quadrant, everything's positive. Students, so sine is the only one positive. Take, only tangent is positive. Calculus, only cosine is positive. So here's the process that we're going to use on these. We're going to draw the picture, including the axes, not just the triangle. Start with the axes. Which quadrant are we in? Draw the triangle so we can figure out the related angle. Are we talking what's positive, what's negative, what numbers? So let's try it out here with some examples. This means we need to take 6 times whatever the sine of 135 is. So I need to figure out where I am if I am trying to evaluate the sine for 135 degrees. So Holly, what quadrant will that put us in? So that's going to put us in the second one. And I need to draw it a little bit to scale. Since the only triangles that I've memorized are 45, 45, 90s, and 30, 60, 90s, I'm going to only be talking for now about angles that hit one of these 3 places. So if I'm going to 135 degrees, am I going to be at this one that's closer to the y-axis, or this one that's right in the middle, or the one that's down here closer to the x-axis? Where will 135 degrees land if I draw it sorted to scale? The one right in the middle. So if this is 135 degrees, my related angle has to be 45 degrees. I draw my triangle, so I'm looking at a 45, 45, 90 triangle. But only the 45 degree angle with the x-axis is going to be my related angle, or I'm going to mess up my plus and minuses. I know for a 45, 45, 90 triangle, it has those proportions, 1, 1, and root 2. Since I'm in second quadrant, I need to be negative and then positive. So negative and then positive. Now I can look at that, and for this 45, sine is opposite over hypotenuse, so 1 over root 2. And I better rationalize that denominator, so I have 6 root 2 over a regular 2, or 3 root 2. Everybody comfortable with that one? Okay, let's try another one then. Oh, well, keep me honest here. I don't know what I did with my paper to verify. Maybe it's this one. So for this one, we need -4 times whatever the tangent of 210 is going to give us. So I need some help knowing where I land with 210. Let's close the book, please. So, Ronald, what quadrant will I be in for 210 degrees?
You're going to be in
Okay, so I need to go 180 degrees and then some extra. How much past that?
30 degrees.
So I'm going to go just 30 degrees past that. So that's going to be my related angle. I'm drawing it so that this looks like the short leg. So that's where the 1's going to go. Hypotenuse is double that. Long leg is root 3. Since I'm in the third quadrant, I'm doing negative and then negative. Now I need tangent for that. So I need opposite over adjacent. So -1 over negative root 3. Those are going to make a plus sign. If we think about, and so, does that make sense? Is tangent supposed to be positive in that quadrant? All students take. Tangent is the only one that's positive. I didn't verify that on this one, did I? Was sine positive here? All students. So sine was positive in second quadrant. So those are making sense for us. So that means I have a denominator I need to rationalize. Root 3 over root 3. I have a negative times a positive, so -4 root 3 over a regular 3, and I finished that one. This time let's do a negative angle. Just like with polar coordinates, draw the axes. Where will we land with negative 330 degrees, Blake? Negative 330 degrees. First quadrant, so I'm going to come around this way, and I'm going to be in the first quadrant. How close do I get to the x-axis? What's my related angle going to be? 30, because I need to go 330, which is 30 less than 360. So my related angle is going to be 30. So this is my short leg. Hypotenuse is double that. Long leg is root 3. First quadrant, everything is positive. So we have root 2 over 3 times whatever the cosine is for our related angle. Adjacent over hypotenuse is going to give us root 3 over 2, so that we end up with root 6 over 6. Questions? Okay, you ready for a complicated one? I think you can do it. So this time we're going to have 3 parts. So it's just like doing 3 problems like we just did, but then putting plus and minus signs between the answers that we get. So we've got to draw the triangle for each piece of this. Figure out what quadrant we're in, draw the triangle, what's that related angle, what's positive, what's negative, what are the numbers for the ratio that we're looking for. So we're going to have 2 times something. 300 degrees puts me in which quadrant, Emma? And how close do I get to my x-axis? What's my related angle going to be? So if I come around 300, I'm going to be about there with 60 degrees left for my related angle. Triangle is always with the x-axis. And then short leg is here, hypotenuse is double, long leg is root 3. And for fourth quadrant, it is +1 and then -3. So, Ashani, sine will be what number over what number for that triangle? Negative root 3 over 2. So the 2's will cancel out, leaving me just with a minus root 3. So then I have minus root 3 times some ratio. So this time I need to go to negative 240 degrees. Emily, where will I be with negative 240 degrees? I'll be in the second quadrant, and so I go 180 and keep going. What will my reference angle be? It will be 60, so I'm going to be up there closer to that. So this is a short leg. This is 60 degrees right there for my related angle. If that's the short leg, the hypotenuse is double. The long leg is √3. But second quadrant is negative for the 1 and positive for the √3. Lydia, if I want now tangent of this angle, what number over what number? So positive √3 over the negative 1 does indeed become a negative √3. So when I multiply those together, I'm going to have plus a regular 3. Then we have plus 3/2 times whatever we get for the cosine of negative 135 degrees. So, Ian, where will I be if I'm at negative 135 degrees? So third quadrant, and what will my related angle be? When I draw it, what will that angle be that I have left here? So if I do 30 and 135, is that going to give me 180? What do I need that related angle to be? How close do I get to 180? I'm going to need 45 degrees in there, so it's going to need to be right there. So far, so good? We draw the triangle with the x-axis. This is the 45 we're using. Both legs are 1, hypotenuse is √2, fourth quadrant is negative, negative. And so now, Hope, if I do cosine, what do I get? But I better rationalize that denominator. So now I have minus 3 √2 over 2 times a regular 2, so over 4. None of those are like terms, so there is my answer. Yes, ma'am.
Do we have to write out all 4 of these, or can we put them in one coordinate?
Right, draw them separately. It's going to get too, you're going to have too much in there. It's going to be too hard to read what you've got. You don't need to make them real big. You know, once in a while, you'll actually end up in the same quadrant, so you can just use that same picture for 2 pieces of it. But if it's exactly the same quadrant, exactly the same triangle. But otherwise, draw them separately so you don't get yourself thoroughly confused. What part of this am I really looking at? Okay, grab those whiteboards. We're going to do some review.